Okay, so now we're going to move into solving simple equations, and this is the section kind of when people are talking about doing algebra. This is what they mean. We're going to be trying to get a variable by itself, and when doing that, we have found out the value of that variable. So for starters, since this is a process that there's a lot of things that can kind of go wrong along the way, it is very helpful to know how to check a solution or test a solution. So in this case, we have 7x plus 1 is equal to 2x. And yes, we haven't talked about how to solve this problem, but we're introducing this concept. So let's say that we did know how to solve this problem. We got a result that says x is equal to negative 2. How do we test it? Well, we test it by evaluating it, and we have seen that before. So we evaluate it by plugging in negative 2 into both sides for x, so we replace it or substitute it, and then we just evaluate each side. So in this case, the right side, 2 times negative 2 is 4, 7 times negative 2 is 14, which becomes negative 13, and what that cross through the equal sign means is that it's not equal to, which makes sense. Negative 13 is not equal to negative 4. And when that happens, we can say that it is not a solution. Let's see another example. X squared plus x is equal to 2. First question we're asking is x is equal to 1 a solution? So first step is the same. We're going to plug in 1 for x wherever we see it. In this case, it's only on the left side of the equation. And then we're going to evaluate. Well, 1 squared is 1, plus 1 is 2. So that tells me that x is equal to 1 is a solution. So that's what we're looking for. If the two sides are equal to each other, great, our answer is correct. If it is not, then we did something wrong, our answer is incorrect, and we need to go back and check something. Something that's worth mentioning, though, is sometimes in mathematics we kind of have this idea of, okay, I checked something. Was that not a solution? Great. Or it's not. I'm done. I have to go back and check it. Or is this a solution? Great. I'm done because I found it. But that's not always the case. Sometimes with algebra questions you can have multiple solutions. So don't kind of, if you are doing a problem and you get through all of the parts and all of the process, if your answer works, great, that means you got part of the question right and possibly all of the question right, but there might be more to it. So that can happen. So when you're testing a solution, if you have multiple options, like let's say they want you to check to see if 1, 5, and 7 are solutions. If you check 1 and it works, that doesn't mean the other 2 work, which kind of spoil it for this one. But if I plug in negative 2 into both of those spots, negative 2 squared gets me 4, plus negative 2 will get me 2, and so both sides are equal, and so x is a solution. X equals negative 2 is a solution. Okay, so definitions here. Almost seems silly to kind of write all of them down, but it is a good starting point. If I have something that I know that one side is equal to each other, that A is equal to B, what I can do is I can add something to both sides, and both sides will remain equal. I can subtract things from both sides and they'll remain equal. I can multiply things. I can divide things. All of those things will not change equality. Sometimes if C is 0, some weird things happen. But in general, all of those things will hold true. And so kind of a nice summary, because it seems silly to memorize this table, is that if you do something to one side, you have to do it to the other side. And also, if you're trying to undo something, do the opposite sign of it. So you probably won't see this breakdown very much, but that's all it's saying, is that when we're doing these algebra tricks, we're allowed to do them because of these properties. So let's get into solving a question. So right here I have x minus 2 is equal to 7, and I know with the properties of algebra, what I can do is I can add a number to both sides. If it's the same number, then the equation still holds, or the equality still holds. So what I want to do is, and this is kind of the goal in general in almost all of algebra, honestly, is I want to get that variable by itself. I want to isolate my x. And so the thing that's right next to my x is a negative 2. I want to move that to the other side. So, well, the opposite of subtraction is addition, so I'm going to add 2 to both sides. So I'm left with x is equal to 9. And I could go back and check, but it's almost trivial at this point. It's pretty quick to see 9 minus 2 is 7. But that's what I'm talking about, is that if you've gone through your process and you get an answer, you should be able to check it. Same concept with this one. I have x plus 3 is equal to 1. I want x by itself. the opposite of addition is subtraction. So I subtract 3 from both sides. 1 minus 3 is negative 2. Now we have a fraction kind of showing up. I have x minus 4 is equal to 1/2. I want to get x by itself. That negative 1/4 is next to it, so I'm going to add 1/4 to both sides. And then I would use a little bit of the fractions that we've seen probably quite some time ago at this point. If I'm trying to add 1/2 and 1/4, I would get a common denominator. It would be 2/4 plus 1/4, and so I would get a result of x is equal to 3/4. Or with a decimal example, here, notice how that I have a number first and then x. That's perfectly fine. Since it's addition, those things commute, which is a fancy way of saying I could flip 0.3 and x. I could make it x plus 0.3 and it's the same thing. So I'm going to just use what I've done before. I'm going to subtract 0.3 from both sides. I'm left with x is equal to 2.5. Okay, moving on to multiplication and division. Here I have negative 8x is equal to negative 32. And just like with the last slide, the opposite of addition was subtraction. The opposite of subtraction was addition. Here, the opposite of multiplication is division. So I'm going to divide both sides by negative 8. And I'm left with x is equal to 4. And now we're starting to get into territory that it might be a good idea to check your answers, because it is easy to kind of make a small error when you're multiplying or dividing or you're typing things into a calculator. Here I have x over 3 is equal to 1 over 2. Well, we've seen this before. This is cross multiplication. But what we can really do is this is x divided by 3. So we can save ourselves a step in this cross multiplication process by actually just multiplying both sides by 3. And then we know 3 is going to be a whole number, so 1/2 times 3 over 1 gets me x is equal to 3/2. Okay, for a question like this, there's two options to do it. Kind of to make it so that it's a standard in this course, if I'm trying to solve for this question, I have 3 times x plus 5 is equal to negative 6. What I'm going to do first is I'm going to use the distributive property to distribute that 3 to both parts of the things inside the parentheses. So then the problem becomes 3x plus 15 is equal to negative 6. And then from there, I can kind of use the process of, okay, I'm going to subtract 15 over. Negative 6 minus 15 gets me negative 21. Divide both sides by 3, I'll get x is equal to negative 7. So the reason why we're kind of making that standard in this course is now we have a pretty complex example, but we know what we saw before is that if I can distribute something, that should be my first step. So in this question, I'm going to distribute the negative 3 to the two things inside the parentheses, the 2x and the positive 4. So then my new equation becomes 4x minus 6x minus 12 is equal to 22. And then I'm going to combine like terms on the left side. 4x minus 6x is equal to negative 2x. And then now I kind of fall back to what we did in the last lecture of saying, okay, this is a two-step equation. I'm going to add 12 to both sides. I'm going to divide by negative 2. And I didn't write the answer, but x is going to equal negative 17. So this is a good question for you to kind of review because there's a lot of really good steps involved in this one. We have a distributive property, we have a combining like terms, we have a two-step equation. So honestly, if you feel good about everything that I did in example 2 and possibly could do it on your own, I would say you've done very well kind of keeping track of what we've done up to this point in solving algebraic equations. So this question is one of those that if it's the first time you've seen it, or maybe it's been a while since you've seen an equation of this type, it becomes an issue of what do I do to start it? Because I have an x on both sides, so I can't kind of use the mentality of saying I'm going to get x by itself. Because if I start to move things around, I'll still have x's on both sides. So to resolve that, what we do is we move an x to one side. We kind of choose which side we're going to. And generally, out of preference, what I do is I just kind of take the smallest x. So in this case, the negative x. I'm going to add x to both sides. And now within that one step, I'm going to get a two-step equation. 7x minus 10 is equal to negative 3. I add 10 to both sides. I divide both sides by 7, and so I get x is equal to 1. So this is a really great example of a fairly kind of, it seems like a difficult problem, but once you see the trick, it becomes a pretty simple thing for us to solve. Similar kind of issue here. I have an m on both sides of the equation, but I also have things in front of my parentheses. So what takes precedence is that distributive property. I'm going to distribute two things on the left side, and I'm going to distribute the two things on the right side. So 3 times 2n gets me 6m, 3 times negative 4 gets me negative 12, 5 times n gets me 5m, 5 times 5 gets me 25. And now I'm going to move the 5m to the other side, so subtract 5m. Get m minus 12 is equal to 25. 12 to both sides, I'll get m is equal to 37. Solving literal equations. This is a pretty difficult concept for a lot of people, but really if you feel comfortable with all of your algebra rules, like you've been tracking why I'm doing these things, why those properties are true, and what I'm doing, these aren't really that hard because that's all we're doing is we're doing more algebra. But we don't have any numbers, so if we've been using, or if you've been using kind of shortcuts to kind of get your way to the end because you are good with 2s or 5s or 10s or something like that, those aren't going to work anymore because all we have are letters. So we're going to kind of rely on the algebraic process and how to get to the final answer. And if we do that, you aren't going to see anything too complicated other than the last example on this page, but we're getting ahead of ourselves. So when you're given a literal equation and you want to solve for it, it's going to have to tell you what you're solving for because we have 3 variables. We don't know which one we want to isolate. So in this question, we say, okay, we want to get m by itself. Well, I notice that it's m divided by v, so that just means in order to get m by itself, I multiply both sides by v, and I'm done with the question. D times v gets me m. A little bit more difficult of a question here. I have t is equal to x plus y over 4, solve for y. Okay, well, to get y by itself, I'm going to have to move the 4 over first, so I'm going to multiply both sides by 4. I'll get 4t is equal to x plus y. And now I'm trying to solve for y, so I subtract both sides by x. And honestly, I think this is one of the big issues that people have with this process, is usually when you're solving, or what we've seen up to this point with algebra, is you get one answer. You get 24 or a decimal or something, where in this case I have 2 unlike terms, and that's perfectly fine. My final answer is 4t minus x. That's what y is equal to, and that's perfectly okay. So don't try and kind of brute force something that you can't really do. You can only combine things if there are like terms when you're trying to add or subtract. So this question is probably higher than anything you'll see on a test, and probably more difficult than anything in my math lab. There might be one question in my math lab of this level. And the reason why this is so difficult is if you don't have a strong algebra background, one of the steps we technically don't know what it is yet. So it might seem like a little bit of a magical step. But let's dive right into it. So I'm solving for x. I have z is equal to xy minus xt. Well, I have 2 of these separate x's. So what I'm going to need to do is I'm going to make them into a single x, and I do that by kind of doing the reverse distributive property. Or if you have a strong algebra background, basically what I'm doing is factoring. But we're going to pretend like we don't know what factoring is. So I'm going to reverse the distributive property, so instead of multiplying x by both terms, I'm going to pull out an x out of both terms, so I should have an x in front of my y and my t. So I call it the reverse distributive property because if I were to take x and multiply both things in the parentheses, I would get the expression that is directly above it, xy minus xt. And now, since I'm solving for x, I'm going to divide both sides by, it seems like a pretty terrifying term, but it is multiplication, so I'm going to divide both sides by y minus t. And that's my final answer. X is equal to z over y minus t.